Our application, ErrFilter, allows an analyst to explore, contrast, and understand models using underlying instances in addition to statistical summaries. We demonstrate our tool specifically on the deception detection task in social media. Our tool provides the analyst access to the underlying instance data for the purpose of error analysis. This is especially useful when these instances are images and can be consumed rapidly. First, we will characterize our models by looking at some representative instances for each class. We first pick a model, in this case image only, and look at instances sorted by the model's confidence. We use model confidence to help us find themes that are characteristic of each class. We add filters for the model's correctness, prediction, and confidence. The data you see in the center of the interface matches whatever filters are active. The left-hand column shows the tweet and corresponding image. The rest of the columns correspond to whatever filters are currently selected. Right now, the data is sorted by confidence, highest to lowest, which you can see on the rightmost column. When we look at the clickbait class, we can see that most instances are from the news media and are photographs of politicians. The conspiracy class appears to consist mostly of infographics. The hoax class consists of photographs of text, which are often newsprint. Finally, the satire class also consists of photographs of people, similar to the clickbait class. However, in this case, these people tend not to be politicians, and the photographs are taken in everyday scenes with natural lighting. Next, we'll look at the model errors. Let's take a look at the case when the model predicted conspiracy, but was wrong. Several of the most confident incorrect predictions are infographics, which is typical of the conspiracy theory class, so we can see why the model made this error. We'll do the same thing for hoaxes as well. Here we can see that many of the most confident misclassifications are photographs of text. This makes sense if you remember that the hoax class has a lot of photographs of newspaper articles. We conclude that the model is overgeneralizing for these two classes. Now we will use the tool to understand the differences between models. To compare across models, we'll filter instances where the text-only model makes correct predictions, but the image-only model makes incorrect predictions. We'll also look at the ground truth distribution to identify the error biases of the models. When the text-only model is correct and the image-only model is incorrect, predictions tend to be hoaxes more than any other class. Similarly, when the image-only model is correct, but the text-only model is incorrect, satire and clickbait classes are a little more common than the others. Now we'll try to find cases where the joint model was better than both the text and image-only models. We select filters where the image-only and the text-only models were incorrect, but the joint model predicted the correct class. Looking at the distribution over the ground truth labels, we see that the joint model shows a large improvement with satire and clickbaits compared to the other classes. We could look at each class individually to better understand cases where both text and image signals together improve the classification. Finally, we present work in progress that uses visualization to overview an ensemble of all the model predictions. We concatenated the predicted probabilities from all models into a single vector and clustered these vectors multiple times using k-means to find overlapping clusters. The visualization helps you see when there is overlap between clusters by placing them together. Darker colors correspond to clusters that are more pure, having instances of mostly one class. This visualization also allows us to identify pathways between instances, for example, from conspiracy to satire. In the pathway shown, the images gradually change from infographics representative of conspiracies to examples of hoaxes which tend to contain text. The transition from satire to clickbait starts with everyday images of people and ends with an image of a pundit in a studio. ErrFilter has helped us qualitatively understand the decision-making processes of different models. We also better understood the strengths and weaknesses of each model. Our broader goal is to reduce the dependency on single numerical metrics, for example, F-score, for evaluating model performance. We believe that quantitative error analysis should be augmented with exploratory and qualitative error analysis.